Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of April 14th this time around. The moon, it's another week of quite a bit of moon, but it's waning. And so it starts near full, and it ends the week about half full, and it will be then rising later and later as the week goes on. So we have a little bit better evening skies by the end of the week to be able to go out and observe some things. Let's start in the morning sky, however. We've been watching the planets in the evening sky. We've talked a couple of times about a little bit of a warning. Here they come in the morning sky, and here they are. By the end of the week, Venus will rise about an hour and a half before the sun, which means it should be well up out of the sun's glow. By the beginning of the week, at the beginning of the week, you'll be able to see Venus in the morning sky, no doubt about it. It's going to keep rising more and more above the sun, further and further away from the sun. So Saturn sits about 5 degrees below Venus, and by the end of the week, it'll be rising about an hour before the sun. Venus, no problem. Big, bright object. You can pull it out of the glow of sunrise. You've been able to see it probably for the last week or more. But Saturn, not nearly as bright, a much more challenging object for us to see. It sits about 5 degrees below Venus. So when you see Venus good and clear of the horizon, get your binoculars out and see if you can pick out Saturn below there. I think you can. This is far enough above, rising enough before the sun that I think we should be able to get this in the morning sky. Now in the evening skies, we've been tracking Mars. Remember, we look in the evening sky, we've got Orion, we're going to talk about a little bit over here, getting close to setting. We've got Taurus above Orion with the big, bright Jupiter there. And then we move east from Taurus, and we come to Gemini. And in Gemini, we have Castor and Pollux, the two bright stars. Last week, we see that Mars was lined up with Castor and Pollux, and now it's going to continue to move east of Castor and Pollux and not be lined up with those two bright stars anymore. As it does so, again, near the end of the week, it says a week's end, let's call it at week's end, okay? Near the end of the week, Mars will be about directly above the star Zeta Cancri, the Zeta star in Cancer, and that's a 4.7 magnitude star. Good dark skies, you'll see it. If you don't have really good dark skies, binoculars will pull it out, no problem at all. Mars is almost directly north of there, about 4.5 degrees. It's about half a fist width at arm's length, remember. And so you'll see Mars above Zeta Cancri, and it's moving toward the bright open star cluster M44. M44 is a nice, rich, beautiful cluster of stars. You can see that without any binoculars or anything. That's a nice, big, fuzzy patch of stars. So Mars is going to continue to close on M44 in the coming weeks. Zeta Cancri is a multiple star system. There's two stars in orbit around each other with about a 60-year period, but they're only separated by an arc second. I don't think you're going to see those stars as individual stars. But they have a third star in the system that has something on the order of a 1,200-year period that orbits the other two stars, separated by about 6 arc seconds. So you will see this as two stars. When you have your small telescope and you're looking at this system, you'll see two stars there, but one of the stars is actually a binary star in and of itself. Now, all of this, so basically, we know that there are two major classes of people in the world. Those of you, I've said this before, those of you who've been watching these little videos right from the beginning several years ago, and those of you who wish you'd been watching these right from the beginning several years ago. That's really it, right? And all of this then should seem like, for those of you who've been watching, like deja vu all over again or something like that, because what's happened is Mars is now, as we caught up and passed Mars went into retrograde motion, and it looked like it was moving backward. It looked like it was moving westward against the background stars. Normally it moves eastward. So it's been tracking through this region eastward for a long time, and then we caught up and passed Mars, and it went in retrograde motion, and it passed all of these objects. So we've talked about all these objects before because Mars had gone back through them, and now it's went back through them again in retrograde motion, and now it's back in prograde motion. This time it's going to get far enough past them that its next retrograde loop won't bring them back to this region won't bring Mars back to this region of the sky. So anyway, if all of this sounds familiar, it should be familiar because we've talked about this region of the sky as Mars has danced through here for a long time now. Mars is just going to keep on moving to the east. For the moon this week, later in the week, in the early morning, about 3:30 in the morning, you'll find the moon about 90% full still on the 16th, and it'll be sitting about 7 degrees to the west of the bright orange star Antares in Scorpius. And then by the next morning at about 3:30 in the morning, it'll be about 5 degrees to the east of Antares. So after midnight, a good bit, you're going to have to get up to see the moon near the bright orange star Antares. On the 21st, early morning of the 21st, the very end of the week we're talking about, the night of the 20th, but in the early morning of the 21st, the half full moon will sit below Pluto by about 2 degrees. So actually, I think if I remember, anyway, it's right near Pluto. I think Pluto's actually below the moon at that time, but it's about 2 degrees. This is all sort of academic. With a half full moon, Pluto's very hard to see. It's right at the limit of a lot of telescopes to be able to even see it. With a half full moon sitting so close to it, the light's going to wash it out. I don't think even with your telescope you're going to be able to see that pairing. So let's go back. Let's think about this Beehive Cluster, M44, that Mars is approaching, sitting about 6.5 degrees away from. So a cluster of stars is a beautiful thing. A cluster of stars is born out of all of the stars in there were born out of the same cloud of gas at the same time. And so typically how that happens, it's not the only way that happens, but typically how that happens, you got a cloud of gas that's sitting around and it's happy as can be, right? You got gravity trying to pull that gas in. You got gas pressure, maybe radiation pressure, but really gas pressure pushing that cloud of gas outward. And those things cancel each other out. We say they're in hydrostatic equilibrium. You don't have any collapse. You don't have any expansion. Those things just sort of equal each other out. Now, what can happen, other things can happen, but what can happen is a supernova explosion could occur, and the shock wave causes a condensation, and it causes gravity to win, and you collapse those out. You could just have natural perturbations, fluctuations, material get close enough to each other to start accreting other material and make stars. But usually a supernova will really trigger this. And so you get all of these stars born at the same time. We love clusters because they were all born out of the same cloud of gas. That means they all have the same chemical starting point, and they're all the same age. And so we can start to look at differences in the stars in here and say it's due to something other than chemical difference in age. And they're laboratories for us to understand stellar evolution. They're really great laboratories. And M44 is about 600 million years old. And that sounds old, but it's really on the younger side of star clusters because you think about the Earth, there's 4.5 billion years old. The universe is almost 14 billion years old. So we're talking billions of years for a lot of structures in the universe, a lot of thoughts about a lot of things in the universe. And so 600 million years is pretty young. So this supernova explosion, if that's what happened here that caused this cloud of stars to collapse into a bunch of bright, glittering, beautiful stars, is it's about 600 million years old. Now, at sunset, remember, later in the week, the moon will be rising later and later, so we have a chance at sunset to see interesting objects. And let's catch Orion, because Orion's going to be gone until fall. Okay, we're gonna be done with Orion. So let's really quickly, we can catch Orion, and we have the 3 stars in the belt of Orion. The Orion Nebula, M42, sits down here as a good naked eye fuzzy object. You got a telescope. It's a fantastic telescope object. Cloud of gas and dust wrapping around there that looks fantastic. It's among the best telescopic objects in the sky, I think, without, just looking through the eyepiece. And so this is a star birth region. This is a cloud of gas, like we were just talking about here, from which stars can collapse and form. And they're doing that. And the Orion Nebula cluster is a cluster of stars like the Beehive Cluster, the trapezium. Those stars in the core of the Orion Nebula are part of this cluster. And this is a new cluster. You still see that cloud of gas. It's the cocoon from which those stars were formed. You still see there that makes that beautiful nebula. And so these stars are only about 2 million years old. These are about as young as stars as you're going to see in star clusters like that, because if they're much younger than that, the cocoon still shrouds them. It just looks like a nebula. And you got to blow that material away, accrete that material onto the stars, and then blow away the remaining material with a pressure. So we got a very young cluster here, and this is what's going on. This is what happened 600 million years ago over here. We see this happening 2 million years ago. We marked Betelgeuse, the bright orange star that is the shoulder star there, because it's a red supergiant star. It's a good candidate at some point to become a supernova that can trigger star formation like we're seeing here in here. So these are great things for us to think about. Catch Orion before it's gone for the season, before we move into summer and you don't have any chance to catch it anymore. Here in April, good chance to get a good last look at Orion. That's what we got for you. It's a great week. Every week is a great week, but this is a good week with Venus and Saturn making their appearance in the morning sky, Mars showing the way to a relatively faint but easy to find multiple star system and closing on the Beehive Cluster, the moon near Antares to see, and then we can think about the Orion Nebula one last time before we head into summer. So as always, everyone, thanks for watching, and we hope you have a great week ahead.